Hey everyone, welcome. I'm Dennis Fisher. I'm here with Mark Ellzey from the Censys research team to talk about some Kubernetes bugs that were disclosed this week. And Mark, you wrote a very cool blog post on them for the Censys blog about sort of the impact of the bugs and tied it to some research you had done a few years ago that was kind of related to these vulnerabilities. You and I were going back and forth when the vulnerabilities were first disclosed this week about what the effect was, what the potential, attacker value might be. And at first, it didn't seem like it was super clear how valuable they'd be. But after you dug into it a little bit, turns out, especially one of those bugs when combined with the others could be very, very valuable. So, what was the overall impact that you saw from these bugs, just looking at them from an attacker value standpoint?
I think it all comes down to really whether those ingress controllers, the NGINX ingress controller, is directly connected to the internet. Because my initial thought is that Kubernetes is very secure by default, and it takes a lot of effort and work to actually unsecure it. You have the API server that everything kind of runs through. I also want to preface all this is that I'm not a Kubernetes expert, but just by being in tech for so long, I've dealt with it. Um, and my previous research was literally finding API servers that were unauthenticated, and you could talk to them. You could grab the pod names, you could get all the namespaces, you could start up pods, and that in itself, that misconfiguration is it takes work. You have to go and modify in a init script, modify the Kubernetes or the API server command lines, and so when this came out, I thought, well, if it's not an open API server, then it's going to be kind of hard to exploit. You'd either have to be, on the same local network as the or the controller, but even then, there's different network namespaces, so it seemed kind of hard to actually exploit. But the realization is that people are literally just exposing these NGINX ingress controllers directly to the internet by doing a port forward. Or to be honest, I don't even know how this happens. I don't know how you could accidentally do this, but they exist. And so, when they're directly connected to the internet, you bypass the API server, you bypass all the security mechanisms that are in place with Kubernetes, and you could just do the exploit, I guess. Yeah.
So the vulnerable component itself was this, as you mentioned, this NGINX ingress controller. Is there a good reason why you would have that exposed to the internet in general, or do you think it's only sort of by mistake that somebody would do that?
There's absolutely no utility in having that exposed to the internet at
Okay.
all. Yeah.
Okay. So these are, if it's exposed, it's probably either by mistake or just sort of somebody that didn't know what they were doing.
Like I said, I find it hard that it takes effort to do things like this. So yeah, it must be a mistake. Yeah, I mean, obviously, but yeah, it's just a misconfiguration, a mistake. Uh, Sometimes people get desperate when they're trying to fix an issue, right? And so they try all kinds of things. And sometimes, if you're dealing with a firewall, you're oh, let me just open up everything for a bit. Maybe that was a situation where, there was a problem with the cluster. So they're trying to figure out what's going on. So they're like, okay, we'll just set this up. Don't know. I mean, it's just all conjecture, I guess.
Yeah. So can you explain a little bit about what this component is and what it's supposed to be doing on a regular basis, like what the function of the ingress controller is?
Now, preface this again, I'm not an expert, but I understand the fundamental thing that it's trying to do. So, you can do like a Kubernetes kube control port forward, but you can be more dynamic within Kubernetes. And so there's a server that can basically generate Nginx configs that will open up reverse proxies into your application. And that's essentially what this component is doing. You can test whether you're allowed to create this rule set. And what it does is it actually, it's like a Golang thing, and it reads in the request, and then it actually calls out to the NGINX binary to with the -t to test that configuration. Um, and what it was found was that, like the whiz, do we call them wizards? Whiz
Whiz
researchers?
researchers, sure. I'm sure they
Yeah.
call themselves wizards. Yeah.
They figured out they could like inject stuff into that configuration and make it do things that it shouldn't do. Yeah, and there was, I think that's what the specific CVEs were for, were the different parts of the different components or whatever.
Yeah. It's always interesting to me when a set of bugs like this comes out that, you know, obviously is the result of some pretty obscure is not the right word, but very specific type of research that the team was doing. And I always wonder whether it's something that they sort of stumbled on by mistake, or if I think in the post they sort of said we went looking at
Yeah,
these
this
controllers.
it's definitely very targeted. It's something that I would do. I would go find parts, components of Kubernetes, highly used software that is used within Kubernetes. And I would do things like I would grep for like exec, which, that's what it was doing. It was doing like an os.system nginx-t, and those are like usually good places to start. It's it's a really interesting vulnerability because, like, when you're used to something very cool vulnerability wise, you're used to like, oh, heap overflow and all kinds of crazy memory stuff, whereas this was different. It was complex but also elegant and simple. So yeah, I liked it. It's a very cool and interesting vulnerability.
Yeah, it was. It was slick. All right, Mark, thanks for your time, man. And thanks so much for the blog post. It was cool research.
All right, thanks.